Read with me. Ready, read. Determine the prime factorization of numbers. Problem number 1. Ready, read. What is the prime factorization of 6? Step 1. Ready, read. Determine the prime factorization of the number using a factorization tree. Here we have the number 6 and the first two branches of our factorization tree. Step 1a. Break the number into two factors. Circle prime numbers if any. There are two ways to multiply to a product of 6. That is 1 times 6 and 2 times 3. So which pair do you use? Or more importantly, which pair do you not use in prime factorization trees? In prime factorization trees, we do not use the pair that has 1 and the given number. We can only continue a factorization tree if we use two different numbers than the number above. In that case, it leaves us with only 2 times 3, 2 and 3. Circle prime numbers if any. 2 is a prime number because there is no other way to multiply and get 2 other than 1 times 2, and we just said we don't use that pair. And that is the definition of a prime number, that there are no other pairs. So 2 is a prime number. 3 is also a prime number because there is no way to multiply and get 3 other than 1 times 3. If a factor from our factor tree is composite, continue to break it down until only prime numbers are left. In our problem for number 6, our two factors, 2 and 3, are both prime numbers. Therefore, they are not composite numbers. Composite numbers and prime numbers are opposite of each other. So we do not need to continue breaking down because we have only prime number endpoints. Step 2. Ready, read. Write the prime factorization. Use exponents if necessary. To write the prime factorization statement, we need to complete this equation down below using these prime number endpoints. 6 is equal to 2 times 3. These are the only two prime numbers in the prime factorization tree, so this is our final prime factorization statement. Step 3. Ready, read. Check and interpret the factorization. Interpret means to explain the meaning of. So we want to explain the meaning of this prime factorization of 6. We can read this sentence by saying 2 times 3 is the prime factorization of 6 because 2 times 3 shows 6 as the product of prime numbers. I will guide you through problem 2 step by step. Let's read problem 2. Ready, read. What is the prime factorization of 10? Step 1. Ready, read. Determine the prime factorization of the number using a factorization tree. Here's the number 10 and the first two branches of your factorization tree already provided for you. Step 1a. Ready, read. Break the number into two factors. Circle prime numbers if any. And step 1b. Ready, read. If a factor is composite, continue to break it down until only prime numbers are left. Your turn. The factorization tree of 10 begins by breaking 10 into the factors 2 and 5. The only other possibility for 10 was 1 times 10, and we cannot use the pair that has 1 and the number when doing a factorization tree. 2 is a prime number, so that should be circled, and 5 is also a prime number because there is no other way to multiply and get 5 other than 1 times 5. And so we do not need to continue a breakdown because at this point we have all prime numbers at the endpoints. Step 2. Ready, read. Write the prime factorization. Use exponents if necessary. Complete the equation below using the prime factor numbers. The prime factorization of 10 is equal to 2 times 5. Step 3. Ready, read. Check and interpret the factorization. Use the information from problem 2 to read your final statement. 2 times 5 is the prime factorization of 10 because it represents 10 as the product of prime numbers. Problem number 3. Ready, read. What is the prime factorization of 12? Step 1. Ready, read. Determine the prime factorization of the number using a factorization tree. Step 1a. Break the number into 2 factors and circle prime numbers if any. Step 1b. If a factor is composite, continue to break it down until only prime numbers are left. There are 3 different ways to multiply to a product of 12. 1 times 12, which we will not use, then 2 times 6, and 3 times 4. Now I'll show you in a minute why it doesn't matter which one you pick, but I'm going to go ahead and start out with 2 times 6 in this factorization tree. So we have the number 2 and the number 6. Alright, let's go ahead and check out if these are prime numbers. If they are, we will circle them. The number 2 is a prime number. There is no other way to multiply and get 2 other than 1 and 2. But the number 6 is not a prime number. It is a composite number, so we will continue to break it down. What are 2 numbers that multiply and give you 6? You have 1 times 6, which we mentioned on problem number 1 we cannot use, but there's also 2 times 3. So we will break 6 into 2 new factor tree arms with a 2 and a 3 as our multiplication endpoints. 2 is a prime number and 3 is a prime number, and we have only prime numbers that are left. Step 2. Ready, read. Write the prime factorization. Use exponents if necessary. For step 2, we need to organize our prime factor endpoints and use these endpoints to write the prime factorization. 2 times 2 times 3. Now we need to use exponents when we have one factor that's repeated. So here we have the prime factor 2. It's written 2 times, so we can use an exponent to represent 2 times 2 as 2 to the second power. So 12 is equal to 2 to the second power times 3. Step 3. Ready, read. Check and interpret the factorization. 2 to the second power times 3 is the prime factorization of 12 because it represents 12 as the product of prime numbers. So here in the middle is the factor tree for 12 and the prime factorization of 12 that we just completed on the previous problem. The first question we can answer is using 6 and 2 different than using 2 and 6? 6 and 2. 2 is a prime number endpoint, so we circle that number still. And 6 can continue. 2 and 3. These are both prime numbers, so we circle both of these as well. We have 2 times 3 times 2, so we can combine these two 2's into a 2 to the second power times 3, giving us the same factorization as before. So there is no difference in the order in which we put the numbers, 2 then 6, or 6 and 2. The order does not matter. Next, is using 3 and 4 different than using 2 and 6? Okay, well let's go ahead and use the numbers 3 and 4. 3 is a prime number endpoint. We circle it. 4 is not prime. It can be broken down in the factorization tree. 2 times 2 equals 4. And both of these 2's are prime numbers. So now we organize the multiplication of these prime endpoints. 3 times 2 times 2. And we use exponent notation once again to represent 2 times 2 as 2 squared and multiply that 3 that's attached to it, giving us 2 to the second power times 3. And we have the same factorization as before. So we can use any of the pairs in any order as long as we do not use 1 and the given number of the factorization tree. Problem number 4. Ready, read. Read step number 1. Ready, read. "18 is given to you with the first 2 branches of the factorization tree. Read step 1a. Ready, read. And step 1b. Ready, read. All right, begin to break down the number 18 using any factor pair other than 1 and 18. You may begin. 18 can be broken down using the factor pairs of 2 times 9 or 3 times 6. In this case, we're going to use 2 times 9. 2 is a prime endpoint. 9 can be factored down further to 3 times 3. 3 and 3 are both prime endpoints. So we have 3 prime number endpoints and our factorization tree is complete. Read step 2. Ready, read. I'll give you a moment to write the prime factorization. Remember, use exponents if necessary. The written prime factorization of 18 will use the prime number endpoints 2 times 3 times 3. And we will use exponent notation for the repeated multiplication of the 3. And there are 2 of them, 2 times 3 to the second power. Read step 3. Ready? Read. Let's read the final statement for the prime factorization of 18. Ready, read. Practice problem number 5. Ready, read. What is the prime factorization of 24? Let's read step 1. Ready, read. Determine the prime factorization of the number using a factorization tree. Here's the number 24 and the first 2 branches of our factorization tree. Step 1a. Ready, read. Break the number into factors. Circle prime numbers if any. And step 1b. Ready, read. If a factor is composite, continue to break it down until only prime numbers are left. So here's the number 24, and if I think about the different ways to multiply and give 24, I can use any combination I want other than 1 and 24. So the first one that comes to my mind is 4 times 6. Now 4 is not prime, and 6 is not prime. These are both composite numbers. So we will continue to break them down until only prime numbers are left. Let's begin with the 4. 4 can be written as 2 times 2. And 2 are both prime numbers. 6 can be written as 2 times 3. So I circle 2 as a prime number and 3 as a prime number, and we have completed the factorization tree. Step 2. Ready, read. Write the prime factorization. Use exponents if necessary. 24 is equal to 2 times 2 times 2 times 3. We will use 2 to the third power to represent the multiplication of 2 times 2 times 2. So 24 is equal to 2 to the third power times 3. Step 3. Ready, read. Check and interpret the factorization. Let's read our final statement using the information from the page. 2 to the third power times 3 is the prime factorization of 24 because it represents 24 as the product of prime numbers. Problem number 6. You read. Step 1. You read. Ready, read. You have the number 40 with the first two arms of the factorization tree. Step 1a. You read. Step 1b. You read. Use what you know about different ways to multiply to a product of 40 to start completing the factorization tree. 40 is equal to the multiplication of 4 and 10. So those are the first two factors that I have for my factorization tree. If you use the numbers 5 and 8 or 2 and 20, no matter which combination you used, we will see that we end up with the same prime number endpoints. Now 4 is not prime, so I will not circle it. 10 is not prime, so I will not circle it. Both of these numbers are composite numbers, so they needed to be continued. 4 breaks into 2 times 2, both of which are prime, so we circle the 2 and circle the 2. 10 breaks into 2 and 5. 2 is a prime number, and 5 is also a prime number. So check your prime number endpoints and make sure that you have 3 2's with the circle and 1 5 with the circle. Step 2. You read. I'll give you 1 moment to write the prime factorization. The prime factorization without using exponents yet is 2 times 2 times 2 times 5. Now we can use exponent notation to represent these 3 2's that are being multiplied. 2 to the third power times 5. Step 3. You read. Read your final statement. Ready? Read. 2 to the third power times 5 is the prime factorization of 40 because it represents 40 as the product of prime numbers. Practice problem number 7. For step 1, let's read the text that has been highlighted. Ready? Read. Using a factorization tree, break the number into 2 factors. Continue to break it down until only prime numbers are left. Let's read problem 7. Ready? Read. What is the prime factorization of 46? So I have 46 again with the first 2 arms of the factorization tree. And I need to think about 2 numbers that multiply to 46. 46 is an even number. So I know that 2 will work. I just need to figure out what is half of 46. Or what is 46 divided by 2? Well, we can do that. We can set up a long division. We can have a dividend of 46 and a divisor of 2. Can I take 2 from 4? Yes, you can. And how many 2's can you take from 4? You can take 1, 2. You can take 2 2's from 4, so we take them, we subtract. The remainder is 0, and we take a look at the next digit. Bring the 6 down. How many 2's can you take from 6? 1, 2, 3. You can take 3 2's from 6. 3 times 2 is 6, so we take them by subtraction. We're left with 0 remainder, no digits to drop down. We know that 46 is equal to 2 times 23. So up here in my factorization tree for 46, I can break 46 into the factors 2 and 23. 2 is a prime number. 23 is also a prime number. There is no other numbers that multiply and give you 23 other than 1 and 23. Step 2, ready? Read. Write the prime factorization. Use exponents if necessary. The prime factorization of 46 is equal to 2 times 23. Step 3. Ready, read. Check and interpret the factorization. Let's read our statement using the information from the page. 2 times 23 is the prime factorization of 46 because it represents the number 46 as a product of prime numbers. Practice problem number 8. You read problem number 8. I want you to read step number 1 by only reading the highlighted information. You read. Ready? Read. "38 is given to you with the first two arms of the factorization tree. Follow the example from problem 7, knowing that 2 and some number will work. Find what number times 2 equals 38. Set up the long division with 38 as a dividend and 2 as the divisor. How many 2's can you take from 3? You can take 1. So take it through subtraction. You're left with 1 left over. Bring down the 8. How many 2's can you take from 18? You can take 9. 9 times 2 is 18. Take them, and you're left with 0 remainder. No numbers to drop down. We have a perfect division. 38 divided by 2 equals 19. And 19 times 2 equals 38. So the partner number that you found should be 19. 2 is a prime number. 19 is also a prime number. So the factorization tree is complete. Step 2, you read. Use the factor tree to write the prime factorization. 38 is equal to 2 times 19. We have no repeated prime endpoints, so we do not need to use exponents. Step 3, you read. And let's read your final statement all together using the information from the page. 2 times 19 is the prime factorization of 38 because it represents 38 as a product of prime numbers.